Hello everyone, and welcome to the video here on how to take products, quotients of radicals, kind of taking and expanding the product and quotient rule of radicals in general. So let's go ahead and get started real quick. And let's just observe that the first rule for products just says that the nth root of something inside of a radical times the nth root of something else inside of the radical, then basically what it says is we can just put it underneath one radical, so we get the nth root, and then product the two radicands together. So for example, if we have something like the square root of 2 times the square root of 3, this is just the square root of 2 times 3, which is equal to the square root of 6. Let's just note that this rule says that the index to the radicals must be the same. So in other words, if we get the square root of 2 times the cubed root of 3, there's nothing to do. So the only thing that we can write is that this is just the square root of 2 times the cubed root of 3. Regarding the quotient rule, let's just note that the nth root of a over b, we can split this apart as the nth root of a over the nth root of b. So this little rule helps us that when we're given this side here, we can rewrite it underneath 1 to do some simplifying. Or if we have this given this one, then we can basically, what it says, split them apart. So let's just take a look real quick at x squared over 25. This is going to be the square root of x squared over the square root of 25, which is going to be x divided by 25, or x divided by 5. Okay. And if we take special considerations, in general, I probably should say, based upon what we've discussed before, something like this. So that's what we'll be taking a look at, and we can do quite a bit. So let's just note, again, if we have something like the square root of 5 times the square root of 7, let's just note this is the square root of 35. Okay, if we get the square root of 15, and we want to product that times the square root of x, then this is just the square root of 15x. And then our next step would be, if we can, to simplify the number. Let's just take a look at the cubed root of 7x times the cubed root of 2y squared, which is going to be the cubed root of 7x times 2y squared. And really the only thing we can do is product the two numbers, so we get 14xy squared, and that will complete our process. Taking a look at the square root of 49 over 81, we can rewrite this as the square root of 49 over the square root of 81, which is 7 over 9. Real simply, the square root of x over 100 is equal to the square root of x divided by the square root of 100, which is equal to the square root of x divided by 10. So just some real simple things on using those two rules. So the final objective out of this section was to do some simplifying of radicals. So we're going to use this simplifying. Let's just note that if we have the square root of 45, all right, so the idea here is to break this apart as the product of two numbers where we want the product of one of those numbers, we want one of those factors to be something that we can take the square root of. So let's just observe that square root of 45 is 9 times 5. And let's just note that this then is equal to, by the rules going the other way, remember we had the nth root of a times the nth root of b is equal to the nth root of ab. So let's just note we have this part here, so now we're just going to decouple it like this, so we get the square root of 9 times the square root of 5. And notice that the square root of 9 is 3 times the square root of 5. There's nothing to do with that. So we have now simplified that square root of 45 all the way down to this. We get the square root of 3 over 81. Again, we can rewrite this as the square root of 3 over the square root of 81, which is the square root of 3 over 9. Now, as we're going to see in an upcoming video, the whole point, or what we would like to do at the end of the day, is to make sure that there is no radicals in the denominator. But that's for another time. But it is coming. So they call that rationalizing the denominator. So take a look at the cubed root of 16 over 27. And let's just note this is the cubed root then of 16 divided by the cubed root of 27. So again, the question is, can I rewrite the cubed 16 as the product now, where one of them is a perfect cube? And notice that this is going to be the cubed root of 8 times 2. So again, you can come over here and do your 16 is 1 times 16, or 2 times 8, just to come up with your factorization to help you out. And we already know that the cubed root of 27, we've seen this a plethora of times, is already 3. Whereas this now, notice that this 8 comes out of the cubed root as a 2, so we get 2 root 2 divided by 3. So we have now simplified that fraction. All right, so let's take a look at negative square root of 27 ab cubed. Again, the idea now is to see if we can't pick this apart. So the question is, can I rewrite 27 as a product where I have one of them as that I can take the square root of the number? And we know that 27 is 9 times 3. There's not much to do with the a. And notice that the b cubed, I can rewrite b cubed as b to the second times b. So kind of like with the number 27, I rewrite this where I have a square. So the question is can I break this apart where one of them is a square? Kind of helps to bring it out. So notice that this 9 comes out of the square root as a 3, and this b comes out, this b squared comes out as a b. And notice what's left inside. I have a 3, an a, and a b. So I leave those back inside the square roots. So I get the 3, the a, and the b. And we have now simplified. Note that you know you're all done when the powers is smaller than the index. All right, let me repeat that one more time. You know you're done rationalizing a radical when the powers inside the radical are smaller than the index. So we got the square root of a squared b divided by 121, which is the square root of a squared b divided by the square root of 121. So we know that this a squared can come out of the radical, so we get an a, and we're left with our b. And notice that 121 is 11 squared, so we get a over root b divided by 11. So here we get the fifth root of a squared b cubed divided by the fifth root of a to the seventh b to the fourth. So just to take a look, notice we have a fifth root over a fifth root. We know we can recombine that. And then we have some like bases and exponents. We know we can use our rules of exponents as well with the b's here. So notice that in order to use the rules of exponents, first we have to get everything under one radical. And since we have a fifth root in both of them, let's just observe this is a squared b cubed divided by a to the seventh b to the fourth. So note that we get the fifth root All right, so notice that these two a's will cancel out with two of those, or take the difference, 7 minus 2. So I get a to the fifth is going to be on the bottom. For the b's, I got my 4 minus 3, which is 1. So I get my b there. And all of these canceled out, so I get my 1 here. And notice that this is going to equal to splitting the radical again back up. The fifth root of 1 divided by the fifth root of a to the fifth b. And we know that any root of 1 is always just 1. Notice that a to the fifth can come out of the fifth root as a. And we have the fifth root of b. Again, we'll stop here. It's coming up, but we will rationalize the denominator. And that is, how are we going to get rid of the radical that is in the denominator? Somewhere, somehow, somebody a long time ago said that that's what we have to do. I don't know. Fifth root of 96, a to the sixth, b to the fourth, divided by the fifth root of 3a b to the minus 4. All right, so again, I'm noticing I have two radicals, same index. Again, same plan here. We will write these all underneath 1. So I get 96, a to the 6th, b to the 4th, divided by 3a b to the minus 4. So now I have my a's and my b's, and I've got exponents. So again, over here, I noticed I had a b to the negative 4. And I know to write that as a positive exponent, I got to get it up top. And I can't put this up top until it's underneath one exponent, or underneath one radical. So now we can go ahead and note that 3 goes into 96 about 32 times. So a on the bottom, a to the 6th, gives me an a to the 5th. And note here I get this b to the 4th. So I'm going to write it there. And then this b to the 4th, well, that comes up top as a positive exponent. So there's nothing down below except for a 1. So we'll just leave that. So this becomes the fifth root now of 32, a to the 5th, b to the 8th. And again, I can reduce this. Note that 32, we can note that 32 is 2 to the 5th power, and a to the 5th. And note that b to the 8th, I can rewrite this as something to the 5th power, and then something cubed. So this 32 is 2 to the 5th. 2 to the 5th comes out of the root as 2. This a will come out as a. This b will come out as b. And then we have the cubed root of b. I'm sorry, the fifth root of b cubed. And again, let's just observe that this power is smaller than this index, so we know we're done. All right, so that concludes this video. If you have any muddy points, please feel free to share those with me in your warm-up exercise. I hope this helps out, and don't forget to read the assigned readings. I believe it's objectives 1, 2, and 3 for section 10.3. Thanks a lot. Bye.